Okay, so we said aluminum chloride aqueous plus, what was the other one, a carbonate? Was it sodium carbonate?
Yeah, sodium carbonate.
Na2CO3 aqueous. Okay, so the first thing is I want to see ions. Yeah. All right, so let's break aluminum apart. Should I just go through this quickly and then I'll just do it. So I'm going to get aluminum. What's the charge of aluminum? Anybody?
+1?
Well,
No.
+3.
3.
Okay. And so that's, remember that 3-2-1 rule. And I have chloride is going to be, there's 3 chlorides. I'll put the 3 out in front just so you can see it. And that they have a -1. So there's 1 + 3 and 3 -1s. I have 2 sodium pluses. And what's the charge of carbonate have to be if I have 2 sodium pluses? Has to be 2 minus, right? They have to add up to 0. I want to switch partners. So aluminum's going to go with carbonate, and sodium's going to go with chloride. Let's do the easy one. How will sodium and chloride go together? So here's what I don't do this. What I see a lot of people do is they'll go, oh, it's Na2Cl3. Is that okay? Don't do that. That would be bad. You have to balance, so you have to put them together based on their charges. Use the charges. What do we get? So if this is +1 and that's -1, also another don't would be don't go, what did I do wrong there, right? You have to go metal plus non-metal, yeah? Okay, so the only way they're going to go together is NaCl, right? +1 -1. How about the aluminum and the carbonate? How will they go together? How will I make a 0 if I have a -2 and a +3? Anybody? How can we do that? Remember swap and drop? So I'll write that down. Swap and drop. So if I have a -2 there, that's going to be how many aluminums? 2 aluminums. And if I have a +3 there, I'm going to get 3 carbonates. CO3, 3. Yeah? Okay. So then I'm going to write my skeletal equation. AlCl3 aqueous plus Na2CO3 aqueous goes to NaCl aqueous. I'm trying to write it big, but also have enough room here. Let's see, plus Al2CO3. CO3. Let me put it down. Al2CO3, 3. Okay. Oh, so actually, and I jumped ahead. I said, well, sodium's aqueous. Let's balance with coefficients. So I have 2 aluminums here. I'm going to put 2 aluminums there. And then go ahead. And I have 3 carbonates here. I could balance the sodiums 2 and 1, or actually, but better yet, let's balance the chlorines. I have 6 chlorines here, and I want 6 chlorines there. And if I have 6 sodiums here, then I want 3 of these, which also balances the carbonates. Okay? And then I want to find the states. So we decided, whoops, excuse me. We decided sodium chloride was aqueous. The aluminum carbonate is solid. Again, this is from a table. Okay, so at this, that's the balanced equation. Right? Okay, the next one is to write the total ionic. So now I have 2 aluminum chloride aqueous. So I'm going to write that as 2 aluminum 3 plus aqueous. And I have, how many chlorides are there? Sorry about the camera fuzzing a little bit. It tries to autofocus. Apologize. Anyways, I have 3 chlorides per aluminum chloride, but I have 2 of them. So it's actually 2 times 3, which gives me 6 chloride ions minus aqueous. And then how many sodiums do I have? You guys are so quiet, but if 1 sodium carbonate would be 2, but I have 3 sodium carbonates. So that means there's 6 sodium ions aqueous. And then also I have 3 carbonates, right? 3 CO3, 2 minus aqueous goes to, and then over here, sodium chloride's aqueous. So I can write that as ions. There's 6 sodium plus aqueous plus 6 chloride minus aqueous. I'm going to write the aluminum carbonate down below again. So I'm writing it big. You guys can write it smaller than what I'm doing, but I'm just doing it so the camera will pick it up. Plus Al2 CO3 3 solid. So again, as is. I'm not going to break it apart. And so again, if it's a separate ion, it needs to show a charge and show aqueous. If it's an ionic compound, I'm not showing charges. Okay? Let's continue. Cancel out the spectator ions. Would you guys like me to rewrite it, or can I just cancel over? I'm just going to cancel over because I'm recording this.
So that's what we would write for the total ionic equation.
Yeah, this is the total ionic. So, and the total ionic, let's cross it out. We'll just cross out. What's aqueous on both sides is the sodium and the chloride. So sodium is a spectator ion, didn't do anything, and chloride is a spectator. So let's write what's left. Now I have room. Now it's 2 aluminum 3 plus aqueous plus 3 carbonate 2 minus aqueous goes to Al2 CO3 3 solid. And there's no common denominator, right? Do you see a common denominator like I did in the first one? Denominator. So this is actually the net ionic equation. Okay, I went through that really quick. But I'm also, you guys, this is the formalism. So let's go back through this. So your balanced equation should have coefficients, correct formulas, no charges. Should I write that in green? Just remind you, right? Let me put that up. No charges shown for compounds, right? Over here, ions must show charges.
I think I got it, but so is the reason we didn't write charges for the solid is because it's a solid?
Yeah, because the charges cancel. The charges,
okay.
Let me write that. The charges cancel, so they're not shown, right? But when they're separate as an ion, I must show the charges. What else to say? For all of these, show the states for all 3 steps. And since you guys are using a solubility table, that should be relatively easy once you get the hang of it. Again, I want you, it may be, you know, the hardest steps, I did it really fast. The hardest steps are way back here, right? Breaking it apart correctly and putting it together correctly. If you can do those, some students get stuck on this. And this is essentially coming from your skill with naming.